Welcome to East Tennessee Pinball. I just pulled this transformer and rectifier board out of a Matahari. Had bought this game a little bit ago, and the MPU had corrosion, and the MPU is trashed. So I'm going to put a new Weebly MPU in there. And I was just going through and looking at the board here, checking out the voltages. I unplugged, so I had the input plugged in here. So this is power coming into the board, and the other two are outputs. So I had the power plugged in here. And look at my outputs, these 5 headers up here. So I have 5 different voltages. They're all DC except TP4, which is an AC voltage. Anyway, I was missing a couple of them, so I'm like, okay, I'm gonna pull this board out, look at it properly, check out the header. And I was basically, so to take this board off here, it's got these little clips on here, but there's also these 3 bolts. These bolts bolt the board back to it. But the other thing, there's, if you look on the back side, if you can see down in there, well, there you go. See those black square, black looking rectangles? Those are bridge rectifiers, and unfortunately what's missing is there's supposed to be this piece here is supposed to go back there. So basically the reason this board is bowed is because it's squeezed down with this missing. So this is the heat sink that transfers the heat from those bridge rectifiers to this larger plate. And that's probably the reason why these things are not working, is because they overheated and cooked. Because somebody had taken this apart, put it back together, and they didn't put this on there. And this is not from this one. This is from another game I was working on, where I replaced it, and ended up putting the bridge rectifiers on the top, and then you don't need this heat sink. Anyway, which is probably what I'm doing here. So I'm going to take this apart, and I'll show you. I'll test these things, and we'll fix it and get it going. So I went ahead and added that heat sink to the back of this board. I don't know if you can see it. Yeah, you can see it in there, that middle bar, silver middle bar. Tested in the game, and all my voltages were there. This first one here, which is the controlled lighting voltage, it was a little bit low. It's 5.5 volts to the 6.5. And actually, testing this as the diode test, it was a little questionable. It wasn't I wouldn't say it tested bad, but it was a little bit outside the range. You want, when you test between, you put your negative on the positive and go between there and each of the ACs. Let's get between 0.4 and 0.7. That was fine, but when you reverse them, you should get an overload, and or basically no current. And I wasn't getting that, and so it's easier to just go ahead and swap this out right now while I got it on the bench. So I'm going to do that, and I'm going to put in a slightly larger one to be fine. And you can mount these up on top of the board. This first one, especially the first one here, needs a little bit of a heat sink. So I'm going to put on this little heat sink. So I'm going to throw it on there, and I'll show you what I get when I'm done. All right, so I got the old bridge rectifier out. I got the new one in there with the heat sink. I got the old sink over here. It's one slot over, so it's kind of hanging off the edge here, which is fine. I just didn't want it to be pushed underneath this one, because the leads on this one are going through the board. They're cut off fairly short, but I didn't want them to ground out on this thing and short. So anyway, we're ready to throw it in the game, see if we got our voltages. All right, so I got the transformer rectifier board sitting in here. I'm going to measure the voltages. First one here, 6.5, that's good. The second one, 183. That one will actually go up to 215, 220 once it's once the solenoid board is plugged in. TP3, 12.5. That's going to turn into that goes up here, feeds the 5 volt. Jump over to TP5, 45 volts. It's solenoid voltage, and then you got to put it on AC to measure TP4 there, 7.5 volts. That's the GI light. So those are all working. So the next stage is plugging in this connector here, which will light up the solenoid board, make sure we've got our making our 5 volts, and basically converting our what will be 221. This is plugged in, then it gets controlled back down to, well, you can set it about 175, 180, something like that. And then once we get that working, then we can worry about the MPU. And this MPU is, this is what happens when you leave old batteries in there. This board's toast. So it's gonna get a Weebly MPU. Anyway, thanks for watching. Please subscribe. Adios.